Greetings human, Razzy I am. I am an experimental platform. Together my human and I experiment with robotics, electronics, sensors and programming, for the purpose of improving human and robotic interaction. My human, Chris, will tell you more about me.
Thanks, Razzy. I appreciate the introduction. Well, I'd like to discuss a little bit about what Razzy is, its purpose, its capabilities, its future, etc. Razzy started out as an idea almost 4 years ago. It was September of 2016 when I conceived the idea of starting a new project, a big one. And the objective was to create a platform where I could explore and experiment with a lot of different concepts and technologies that are in use today. For example, the Raspberry Pi single board computers. I saw that as an interesting device, very powerful for its size and capability. Just thought it'd be a great device to explore. So I selected that as the main computer system, so to speak, for the robot. But more expansive, I wanted to learn more about how the navigation system works in my car. It knows where I am, I tell it where to go, it magically figures out the route between where I am and where I want to go, and it maps out a course. I sit back and, like a total dummy, just sit there and do what it tells me to do to get there. So I wanted to learn about that capability. I wanted to learn about self-driving cars and how they're able to move through an environment, not run people over, not drive into buildings most of the time, etc. There's a lot of technology there, most of which is way beyond the scope of what I can afford and do it at their level. But I certainly figured I could explore and dig into those different technologies such as LiDAR and infrared sensors, ultrasonics, and that sort of thing to see how they see so that I could implement them into robotics. So the whole device, all of Razzy, is strictly an experimental platform for me to explore and understand those technologies. Now, of course, with that, there's a whole lot more peripheral technologies that can be explored and integrated into the systems, because frankly I wanted to learn about simply the Raspberry Pi, learn a new programming language, Python. It was new and foreign to me. I wanted to learn about computer vision and how that works and how it's evolved and what the capabilities are of it. Wanted to develop a MP3 player. This is a very large MP3 player. Its capabilities are so-so on the audio, but nonetheless it's a large MP3 player. It's also a video player. It can play video clips and so forth. It's got speech synthesis and a number of other things. But nonetheless, the point is it's an experimental platform for me to explore and expand on different technologies. That is its sole purpose. Does it have an end goal? Not really. Its purpose at the end of this, I have no idea. Along the way, I'm going to learn a lot about a lot of technologies. I hope to share it with everybody here on the YouTube channel now. I kind of kept it all to myself in years past, but I think it's important that this information be shared so others can benefit from it. So that pretty much gives you an idea of the beginnings. 2016, September. So it's been worked on, for the most part, on weekends and whenever I got a little free time for the last 4 years. It's changed a lot. The architecture of it's changed substantially from where I started and where I am now. But I'll get into that a little bit more once I open them up. One of the things that I felt was very important about this project is I didn't want it to be a radio-controlled robot, meaning that you sit there with your RC or radio-controlled controls and drive it around and hit a button that it might say something. To me, that's nothing more than just a glorified radio-controlled toy or device of some sort. The design implementation of everything is to allow it to be as autonomous as possible, to interact, to move around, that sort of thing. I don't want to have to sit there and babysit it or make it do things to interact in an environment with people or without people. So this is not going to be radio controlled. I have no intentions of doing that. The closest to it is adding a manual control joystick so I can drive it around and get it into positions, or maybe take it from the car and bring it into the building where I might be showing it off, something to that effect. Now, as you can see inside, there's a very large area in here. Roughly it's, I'm going to say about 10 inches by 10 inches deep. Maybe that's close to 20 inches tall. That's the core of the system. On here there's 3 panels, one on each side, the back is open, where we can mount different computers, such as Arduinos and of course Raspberry Pis, to do different functions. It's very modular, the whole system. Initially, when I started this project, because I had really no understanding of a lot of these technologies, the Raspberry Pi, Python, the sensors that are available, the sensors that I would eventually also purchase along the way, had no idea of what everything was capable of and how much demand on computing processors there was. So literally I started out with one Raspberry Pi to do all of this. And over time, or a very short period of time, I learned very rapidly that that wasn't going to be the case. I would have to dig into a lot more additional computers. Right now, I believe it has 6, maybe 7 Raspberry Pis on it, and at least one Arduino. I'm probably going to be adding another one here in the very near term to handle more sensors. I'll get into a lot more of these technical details in the architecture of that level in a later video, where I can be very specific about how I did something and why I did it and why I laid it out the way it is. Just to go over some of the basic features of it, what it's capable of, and I'm not sure what's in the view of the camera. Down here we've got a LiDAR, a spinning 360-degree LiDAR. I'm only using 180 degrees of it. I only really want to see what's forward. So I'm using that as a LiDAR system down here. Those became very economical along the way, so I figured I better try to incorporate it. Previously, I tried about 4 different homemade varieties of this using stepper motors, servo motors, infrareds, laser sensors, none that were all integrated like this LiDAR system. So it's got LiDAR. It's got speakers here and here with an amplifier so that I can play music and speak. When he speaks, it plays through the speakers and you can hear it. Coming up from there, or well, actually down at the base, it's I've had 4 different drive systems on the robot since its creation. I started out with power window motors, and I was driving those directly through a very basic driver board, but found that to be very problematic. Then I went to a stepper motor system that initially worked okay, but it wasn't without problems, so I put on another stepper motor drive system with larger stepper motors, Gecko drives, more powerful drives, and a different type of control software working through an Arduino instead of through the Raspberry Pi. Again, that worked but didn't work. And now I'm using back to power window motors, but powered through or driven by a RoboClaw motor drive system, and that has turned out to be a very good system thus far. It's marginally powered, but it's better than what I had before, so I may have to upgrade that again in the future depending on the surface that the robot is moving around on. Hardwood floors has always been no problem. This particular carpeting, where I'm doing a lot of my testing and experimentation, very short nap carpet, it's a very thin pad under it, and with the stepper drive systems they would just sink into that and have a hard time to get rolling. This system goes right on through it and it's happy. And it is a closed loop system as well. It has encoder feedback, so it actually knows that the motors are moving and the wheels are rotating, which will help out a lot more in navigation as I get more into moving around autonomously. Some of the other features, up here there are 2 eyes here and here, and additionally 2 on each side and 2 in the back. And those are infrared sensors, and they have a range of about, I think it's about 70, maybe 80 inches. And those are also to help the robot see what's in the surroundings. And that would work in conjunction with the LiDAR information. At times I may need to compare the 2 measurements and make sure I can actually go to a certain location and not hit anything. It's got passive infrared, so it can detect when a human walks up to it, and he can respond accordingly. These are some lights and buttons. Those are used to allow a human to interact with the robot. Maybe it needs to do something and it's asking you to tell it what to do, giving you 2 options. Hit the red button or hit the green button, or whatever it wants you to do. Up here is a small digital display. It's part of the Sense hat from Raspberry Pi. I put that in there just for giggles. It's got an analog joystick, as I mentioned earlier, as all robots should have. It's got an e-stop button that'll kill power or kill the drive system, and a main power switch back there. The head of the robot has gone through a number of transitions as well. What we've got is a 10.5-inch touchscreen HDMI monitor. It's in the head. There are also 4 cameras. There's a USB camera here and here, 1 on each side. This particular one is used for object detection, people detection, motion detection, and that sort of thing. Here and here are also 2 more cameras. These are the Raspberry Pi cameras. One is the no infrared and the other is the normal camera. The robot is very capable of, in certain situations, recording movies or taking high-resolution photographs in either infrared or no infrared, or in traditional photography with the infrared filter on there. So there's a lot of capability up in here for its visual experimentation, we'll say. Experimenting with how to use object detection to navigate or to see things that it shouldn't run into while it's moving along. Photography to interact with people. It can take a picture of somebody and email it to them. Things of that nature. So there's a lot of interaction up there, and of course a lot of technology. The system runs on 2 sealed lead-acid batteries. It's a 12-volt system right now. It's actually transitioned back and forth between a 12-volt and a 24-volt system 2 or 3 times. I've lost track over many of the experiments thus far. But I just run 2, I think they're 1400 amp-hour sealed lead-acid batteries in series, and that gives it plenty of power. While I'm doing all this experimenting down here, I'm of course running off of an umbilical cord that provides 24 volts from an industrial power supply, so I don't have to keep stopping and charging batteries throughout the day and so forth. I don't know if the camera can pick it up or not, but you'll see Razzy's expression changing frequently through this interview, and those are sensors that provides feedback to Razzy as to whether he's happy. He decides whether he's happy based on the feedback from those sensors. For instance, down here I've got a bumper switch, a tape switch, and when I hit that, he'll put on his sad face. If he sees a human face, it makes him happy, he'll smile. It's an emotional element to the robot that's been programmed into it. I'll get into that in a very detailed video at a later time. As far as the future of the robot, again, I have to remind myself of this. This is an experimental platform to learn and explore about different technologies. There is no end game. And I don't know if you've been in a project that's been running for 3 or 4 years, and you tell your friends and you tell people about it, and one of the first questions that always comes up, what's it going to do? And I get caught up in that mentality where, oh God, I got to get it done and show people what it can do. And that creates a lot of frustration in a project of this scale. It isn't going to be done, I hope. It's been a lot of fun working on it for 4 years. Yes, there's been a lot of frustration figuring things out. But my objective is to keep learning and exploring and developing maybe some new technologies or techniques and so forth. So the future of Razzy, I hope for many years, is to remain as an experimental platform for me to learn and explore about all these technologies. And along the way, hopefully it can do some demonstrator type activities or interactions, maybe at maker fairs and so forth. Right now it's in a changeover state from how I set up the architecture originally and much of the programming. It had just recently, within the last few months here, I've rewritten the entire main software library for it and took it from one huge large program and split it out into classes and modules and so forth, and done it in a very modern contemporary style because it just simply got too unwieldy. But hopefully in the next few months I'll get everything pieced back together, working happy as an integrated system, and then I can maybe take it out to a maker fair or some other type of event like that and showcase some of his capabilities. But in the meantime, he remains as, and I have to keep in my mind, he will remain as an experimental platform to learn and develop these different technologies. I'm going to be getting into a lot of the detailed aspects of this project in the coming years, and I'll be hopefully doing a lot of videos. I really enjoy doing the videos. I think there's a lot of information that I've learned along the way, which can save people a lot of trouble if they're replicating certain aspects of the robot or maybe trying to create their own Razzy. So I will be doing a video. I don't know the frequency on this. It really depends on my schedule. I work full-time in another world, and I can only do this in my spare time. But the objective at this point with the videos is to go into a specific subject and go through what I learned about it so far, how I did what I did with it, how it integrates with the system, and what I think I need to do to improve that particular subsystem. And that will range everywhere from the LiDAR to its speech synthesis, to its emotional reactions, and a lot of effort, a tremendous amount of effort is going to go into autonomous navigation. Yeah, I know there's a lot of great things out there with SLAM. Primarily all that's running through the ROS, or Robot Operating System software, and that sort of thing. I myself made the conscious decision not to utilize ROS because I wanted more control over how everything was done. So essentially I created my own robot operating system, which kind of hurt me a little bit because trying to implement SLAM without ROS is an extremely difficult challenge. The upside is I'm learning a lot about the SLAM techniques and maybe coming up with some more simplistic algorithms that allow me to do similar functionality that may or may not work. But nonetheless, Razzy is serving the purpose to help me with that endeavor. So that's going to pretty much wrap up this video. I think it got a lot longer than I wanted it to, but I really needed you to understand Razzy and the basis or the core for these future videos that I'll be creating in the coming months and years as to, gee, I'm talking about an analog joystick on Razzy. Well, you wouldn't know what Razzy is unless you watched this video and saw the interview between me and Razzy. Thanks for checking in. I really hope you stick around. I hope you subscribe to this channel. I hope to have a lot of great information that could be of benefit to you if you're a budding roboticist or just into the programming and learning about the sensors and how they're used and so forth. Nonetheless, if you've got a curiosity about these technologies, please subscribe. Maybe give me a big thumbs up for appreciation, and that's how I get paid. You give me a thumbs up and it makes me happy. And certainly tell all your friends about our projects here. Tell your friends, invite them to the channel, say, hey, check this out. The more we grow, the greater the community is, the greater the opportunity is for all of us to share our information and share with each other as makers in a community of makers. Thanks again for watching.